Here's a quick little video on making lights blink with Arduinos. So here's a neopixel. It's got 7 LEDs on it. You can see on the back, even though it's upside down here, there's an in and an out. So the wires are going to come in on the left and they're going to exit on the right into another neopixel array or into nothing. And you just have that. And we're going to be affixing these wires to the that side, the inside. I like to use the darkest wire for the ground, and then everything else just lines up like that, the VCD and the in. And this is a 3-point DuPont connector. So you kind of like get these female connectors, you crimp them onto the ends of the wires. There's tools for this. You can kind of get YouTube tutorials on how to do those DuPont connectors. Let's just quickly go to the soldering part here. So as you can see here, I've got a really nice little soldering station with these magnetic Dr. Octopus clamps, and they are great for holding things. So you're going to want to like get something like that so you can kind of hold the work while you solder it. And then I've got a nice Weller variable soldering iron, very, very nice with a fairly... I also have this nice little reverse fan, so that's going to suck all the smoke and stuff out the back instead of into my lungs, which you don't want. I'm going to tin the ends of these just to make them easier to go on. It's nice to heat the wire and then touch it and let the solder flow onto it. I'm just giving a nice base. I also like to put pads on here, so I'm just going to get a nice little pad on each of these, just so it's got a nice place to land on. And then, let's see, I get the ones out of the way I'm not doing. So I'll start with the blue first up here. Oh, that's ugly. This is just going to be for learning, so I'm not going to worry too much. I'm not doing it to NASA standards here. Sometimes it's nice to twist the ends of the wires so they don't go all over the place, and I don't like that. There we go. They can't be touching each other. This is really ugly. But what I'm essentially making is just a little tester. I'll just keep it for testing certain sequences. I think that is good. Sometimes I put distilled water in that little pad there and I wipe off the excess solder. So what we have now is a kind of testing thing. We've got the DuPont connectors on here. We can quickly drop that on an Arduino and we can start sending code to this. I've done a similar thing with one of those big, you know, those big rolls of the lights. There's the big roll. Can't find it, but I've basically snipped off these four, and it's the same thing. You create code where this is an array, 0, 1, 2, 3, and this is the same thing, 0 to 6, and you just start shooting code down there. Each of them has an individual number. You can kind of just test with the code, like make 0 green, and you see which one lights up green, that kind of thing. I think I've got some notes in some of my code. So with these two things, we'll move on to the Arduino part. Okay, so here's an Arduino. When I have problems with them, I tend to like put red nail polish on them. So this one is suspect, but I do believe I used it last time and it'll work. So what we end up doing is using this FTDI thing. That's this thing on the end. This is the USB cable going right into my laptop. Let me shut off Mr. Soldering Iron. So I'm going to fire. And yet, so here's our Arduino. We're going to pop that on. In my case, it kind of the two boards face each other as opposed to this. Do it like this, you'll get an error. You do it like this, you'll get some success. We've got power, we can see that red light there. And now over here on the laptop, I'm just going to upload the code. I will get in the code at the end of this, but for now, we're just uploading it. And you get these helpful messages. You can see it going up, you can see it writing, and you can also see the FTDI flashing away as it's writing, and it is done. And what's happening now is the code is simply executing on the Arduino. So I'm going to leave this hooked up because this is powering the Arduino, and I'll show you what I'm going to do for the first test. So this first test is, this is an eyeball I've got in a robot, And the way I've got it programmed is it blinks, it kind of looks up by lighting these top three, it looks down by lighting the bottom three, that kind of thing. And so we'll just pop it in. So what I've done is I've got this little extender here so I can get to the individual pins. Here, let me just zoom out a bit. And let me just quickly look. So I've got ground on this purple. So the ground on here is, where are we here? Second from the end. And then the gray is going to be power. That's a VCC. It's going to probably unplug when I plug it in here. Bear with me. Just remember, you've got a little cheat sheet here where it says ground, VCC, in. So VCC is power, ground is ground, in is the data. And here's the data. And in my code, I'm just going to tell you, I've got it on pin 14. So if you look on here, you see the numbers, 11, 12, 13, and then A1, sorry, A0, A2. A0 is actually 14. It was probably better if I would have used a numbered port for this, but I'll tell you why later. And let's take a look at our LED now. And nothing's happening. Why is that? Oh, it's because I'm on A1. I got to be on A0. So A0 is pin 14, and that's actually just sending these commands down to the LED. So this is the bottom. Oh, can we do this? Yeah, I think it's like this. It's looking up. It's looking down. It's blinking. It's just a rat catcher droid that sits there and blinks. I'll get some footage of that later. Oh, I guess maybe it's like this. I'm not sure what's going on there, but that's what it's doing. And it's actually, the way the code is, it's got another cable in my robot that goes out to a second eye, and both of the eyes work in conjunction. So it's an array of 14 LEDs, 0 to 6 on this, and then 7 to 14 on the other one. And they just do the blinky things I've told them to. I'll show you another example with this light ribbon here. So now let's look at the LED light strip. So this is a bit different. You'll notice that the order of the wires is different. We have power on the outside, data in the middle, and ground on the end, as opposed to these guys where you have ground, power in the middle, data on the end, which is the in. So let's hook that up. So let's see, ground was going to be purple. That is the purple to blue. That's why it's nice to have these female to male cables to frig with. We have data in the middle. Yeah, here, I'll just put them all on like that. Power on the outside, data in the middle. And immediately it's lit up, and it's going to run through that sequence, that blink sequence, except there's only 4 lights to work with. So it's only lighting up those ones that it can reach. If you had 7 on here, it would write 3 at a time, 3 at a time, that kind of thing. But yeah, basically that's it. That is how you hook these up. It's from the USB, from your laptop, into the FTDI device, into the Arduino, providing power. When it's in your robot, you can use a power source like a bunch of, oh, look at that. It's doing different colors now. It's doing red. That's the angry eyes. You can use 4 AA batteries. They're 1.5 volts each, so you can get 6, and that's perfectly acceptable to throw at these lights. They're 5 volts, so 6 isn't too bad. Let's take a look at some of the code. So this is the code for the rat catcher droid eyes. I did this the night before con, and when I work fast, I just do really caveman code. You know, I don't optimize it or do arrays or anything like that. I just chuck it all out there. So right away, we've got the include. This is Arduino. This is the Arduino IDE, free, you can download it. You define the library fast LED. That's what I use to flash the LEDs and change them different colors. I tell the program how many LEDs I have. In this case, it was the 2 kind of round eyes, and there's 7 on each one for a total of 14. By pure coincidence, the data pin on the Arduino I'm using is also 14. It could be anything really. No need for a clock pin. There's some comments in here that tell you why, when you need to use a clock pin, if you've got 4 wires. But in this case, we're dealing with 3. Then we have an array, and that's using the variable number of LEDs. Void setup, that's in every Arduino program. We're establishing with the fast LED library. that it's a neopixel, and expect these variables coming your way in the array. Here's a loop, and this is just to have the lights do random things. So basically have these 7 case statements here, and it says pick a random number between 0 and 6. So a total of 7 options. You go full eye, both eyes in the middle, looking upwards, look left, look right, left, right, that kind of thing, both eyes. It's a series of functions. So let's look at the very first function, which is case 0, the full eye open. So basically we have the order of the LEDs, and this is from top to bottom. There's 2 in the top, 3 in the middle, 2 in the bottom. So it is setting it to that color. I believe I'm using a green for that, so or greenish yellow. And that's basically all it does. I've got them labeled here. Top of the left eye, middle of the left eye, bottom of the left eye. And I'm just talking to all of the elements. So these are the individual LEDs, 7 on each eye. And then here I've got the comments to get the top of the right eye, top of the right eye, mid right, that kind of thing. So all these numbers you'll see 0 to 13 for a total of 14 LEDs. Just the order is very strange, the way they're actually referenced on the boards themselves. So the first thing we do is we establish, we turn it on, and then we're going to wait for, so that's, you use that with the show command. You wait a random number of seconds between 2 seconds and 4 seconds. That's in milliseconds. So 2000 milliseconds is 2 seconds. Then we're going to clear, that establishes a blink kind of, and then we're going to turn them black. No, you know what? These, this is some experiment. I guess clearing turns them black automatically. I was at first turning them black to the color, but then the clear command does that. And then a quicker delay between the two, like up to half a second, and then show them again. So that's pretty much what it is. I went to a website and I was able to pick colors and type in these hex codes, and then it would bring back the color. Later on in the code, I think I'm experimenting with actual colors where I will use them by name. Do I have any examples of that? Come on. Yeah, there we go. So down here where I'm turning them into the color red, you can actually call it in a slightly different way, and you can actually use this CRGB command. I believe that's cyan, red, green, blue, and then just tell it red. So some of the basic colors, it understands that. So that's pretty much it, and it just loops through that. If we go back up to the case statement, it's looping through this bit here. Just pick a random number and then go to the case for that random number and then do it. And then go back to the top and start all over again. So as long as it's on and powered, it's going to keep cycling through these. Some of these turn the colors to red, like when he's mad. This is kind of like he's looking up, looking down, that kind of thing. So you're just turning the lights on in each of these functions. Yeah, that's the function void full eye. That's case 0. That's about it. So it's pretty straightforward. It's very ugly. I can see where I'm commenting stuff out. That was probably very rushed, where I probably tried to call it in a big array. Yeah, I'm experimenting here where I'm trying to call these little arrays where I've got multiple LEDs in the array. So like call that array and turn it red and make it look up, but I just have not workshopped it enough to make it work. So at some point I'll go in and clear that up. So when you put this to the Arduino, this is what it looks like when you compile. You just go up here, you set up your, first of all, you tell it what Arduino board you're using. You can go into the drop down here, and this is an Arduino Pro Mini. Next thing you're going to tell it is what COM it's on. So try either one if you don't know, and eventually go through. You can click on board info, and it'll come back with the serial number, and that tells you that it's communicating. I believe if this was on COM1, which is not plugged into anything, and you went board info, yeah, see it cacks on that. So that's how I kind of know that COM7 is working. And then it's a case of just hitting this upload button here. And then you see all this stuff. I've got this set to verbose compiling. Failed uploading. What doesn't it like? Native port, Kenneth. Okay, let me see if I got the port right here. COM7, get board info. All good. Try that again. Yeah, I think it was because I was playing around with the ports. I switched it to 1. So this is what you'll get when it's in verbose. I like verbose because it's like, it talks back to you a lot. You see everything that's happening. Otherwise, it just does something, and down here you'll get a little notification like, ooh, done compiling. You know, but I like this stuff. You can shut that off with this little button down here. And that's essentially it.